now that we have seen type 1 and 2, we're going to do type 3 and 4. So what we're going to change now is when their trig are different, right? So in the last one, we saw type 1 and 2 is when they're the same. It's just that the inverse in the first one is in the inside and on the second one is on the outside. So if you take a look at number 1, at the 4 examples here, you can see that the trig functions are different. So in the first one, it's tangent, cosecant, then cosine and tangent, then sine and cosine, then cosine and cotangent. However, in type 3, the inverse is still on the outside. And luckily for us, we do it the exact same way as type 2. Whenever the inverse is on the outside, you evaluate. So when you evaluate, you always work first with the inside function. So I'm going to do cosecant of pi over 2. Pi over 2 is an axis angle. It's here. So this is 0, 1. Cosecant is the reciprocal of sine. So the sine of pi over 2 is 1. So the cosecant is 1. So this is equal to tangent inverse of 1. Now, I'm evaluating an inverse, so I'm restricted. So I have to think about my restriction. This is the one time you have to do it. Negative pi over 2 to pi over 2. So for tangent to be 1, that's going to be in quadrant 1. So that's pi over 6, pi over 4, pi over 3. And the angle in quadrant 1 that will give that tangent is 1 is pi over 4. So the final answer is pi over 4. Next. Oops. First, I'm going to evaluate the tangent of 5 pi over 3. Okay, so where is 5 pi over 3? This is equal to 5 times 60 degrees, which is 300. That means that I am in quadrant 4, and the reference angle is 60 degrees. So I can draw my little triangle. 60, 30, 2, 1, square root of 3. Tangent is opposite over adjacent. So square root of 3 over 1 is square root of 3. So I'm doing this cosine inverse of the square root of 3. Now I need to think about my restrictions because I'm 0 to pi. So that's here. It's positive. But right away, it should look a little weird, right? Because we know that we can evaluate square root of 3 over 2. But what about the square root of 3 by itself? So if you think about the square root of 3, right? We know that cosine inverse, the domain, has to be between negative 1 to 1. Now, the square root of 1 is 1. So the square root of 3 is definitely bigger than 1. What that means is that this is out of the domain. We can't evaluate the cosine inverse of the square root of 3, so it's undefined. It's like, again, trying to do the square root of a negative 9, right? It's undefined, unless you're in the imaginaries. Okay, let's do another one. So first is the inside. So 5 pi over 6 is equal to 5 times 30, 150. I can draw my little triangle. Here's 30. 2, 1, square root of 3. Cosine is adjacent over hypotenuse. So I have the sine inverse. But remember, I got to think about my quadrant. I am in quadrant 2. And in quadrant 2, cosine is negative. So this is negative square root of 3 over 2. Now I have an inverse, so I'm restricted. So negative pi over 2 to pi over 2. That's here. It's negative, so it's going to be in quadrant 4 for sine. So 1, 2, 3. And the angle in quadrant 4 that will give me that sine is negative radical 3 over 2 is going to be the last one, negative pi over 3. So my final answer is negative pi over 3. One more. So first I'm going to do the cotangent of 3 pi over 2. 3 pi over 2 is an axis angle. So that's 0, negative 1. Cotangent is the reciprocal of tangent, so it's x over y. So it's going to be 0 over negative 1, which will be 0. So I have cosine inverse of 0. I have an inverse now, so I'm restricted, 0 to pi. That's here. For me to get 0, it has to be an axis angle, so 0, pi over 2 of pi. Well, the cosine of 0 is 1. The cosine of pi over 2 is 0. And the cosine of pi is negative 1. So my only possible answer is pi over 2. And there it is. Okay, let's look at the last possible type. So the last type that we have is that the trig functions are different. and that the inverse is on the inside. It's the only last combination we haven't done. So what you're going to do that is that these are going to be really kind of procedural, and I have it underlined. You're going to assign an angle and use SOHCAHTOA. Okay, so the first thing we do is that we grab the inverse part. So again, the inside, right? We're working with the inside first. And we know that when we evaluate an inverse, we input a ratio and we output an angle. And we're going to give a name to this angle. We're going to call it theta. So I have the sine inverse of negative 1/3 is equal to theta, which means that the sine of theta is negative 1/3. Once I write it like that, I can immediately create a triangle using SOHCAHTOA. So this is theta, and sine is opposite over hypotenuse. By the Pythagorean theorem, I have 1 squared plus a squared is equal to 3 squared. That means a squared is equal to 8, which means that a is equal to the square root of 8, which reduces to 2 radical 2 because it has a perfect square of 4 in it. Now this is the part that a lot of people tend to forget, which is the quadrant. You have to really think about the quadrants in trigonometry, okay? How do I know the quadrant? The quadrant is going to come from how you assigned your angle. Which inverse did you assign your angle to? Because that angle has a restriction. So if it's sine inverse, it's negative pi over 2 to pi over 2. So that's this right here. But I can see that my ratio is a negative 1/3. And the only way that I'm going to have a negative ratio for sine has to be that it's going to be in quadrant 4. Everything is positive in quadrant 1, so it has to be quadrant 4. So I have a triangle, I have quadrant 4, so now I have, look back at the original problem, right? What was on the outside? What was the outside function? Now we evaluate the outside function. So the outside function is cosine of theta, because I replaced the inverse with the angle. And now you just use the triangle in the quadrant. So in quadrant 4, cosine is positive, and it is adjacent over hypotenuse. And here's my final answer. So I don't know what the angle is, but I don't need to know. I can figure it out another way by just using SOHCAHTOA in the quadrant. So let's try again. I grab inside, I say theta. So I have the tangent inverse of 4 is equal to theta, which means that the tangent of theta is 4. From this, I can draw a triangle, opposite over adjacent. I have to take a look at what I assign my angle to because I'm going to be restricted. Tangent inverse is restricted from negative pi over 2 to pi over 2, not including the axis angles. It's here. But it's a positive 4. It's a positive ratio. And the only way I'm going to get a positive ratio is if I am in quadrant 1. So this is Q1. So then I look at the outside function again, go back to the original problem. It's cosecant on the outside. So I have the cosecant of theta. And I'm in quadrant 1, so it's positive. Now I need to find the missing side. I haven't done that yet of my triangle. So I have 1 squared plus 4 squared is equal to c squared. That means that c will be the square root of 17. And cosecant is the reciprocal of sine, so it's hypotenuse over opposite. And here's my final answer. Okay, so we're going to end by doing a mixture of all 4. So take a look first at each of these problems and notice how they're all each one of the types. So the first one is they're the same and the inverse is on the inside. This is type 1. Next, they're the same and the inverse is on the outside. This is type 3. Sorry, they're different and the inverse is on the outside. The next one underneath that, they're the same, the inverse is on the outside. This is type 2. And then the last one is they're different, the inverse is on the inside. This is type 4. Maybe reminding you what kind of type they are will allow you to remember the steps. So type 2 and type 3 are done the same way. Anytime the inverse is on the outside, you evaluate. So let's begin with these. So the first thing we're going to do is we're going to look at the inside part, right? These are... Okay, so 4 pi over 3 is equal to 4 times 60 degrees, which is 240. That means I am in quadrant 3. Here's 60. Here's 2, 1, square root of 3. Cotangent, which is the reciprocal of tangent, is adjacent over opposite. So I have the tangent inverse of. And in quadrant 3, cotangent is positive because tangent is positive. So I have 1 over the square root of 3, or rationalize radical 3 over 3. Now I'm evaluating a tangent, an inverse, so I need to think about my restrictions. So I'm here. It's a positive ratio, so I know I'm going to be in quadrant 1. So pi over 6, pi over 4, pi over 3. And the angle that's going to give me that tangent is 1 over square root of 3, which means the cosine is going to get the square root of 3, is pi over 6. So my final answer is pi over 6. Okay, let's do this one. So I have 3 pi over 4 is 3 times 45 degrees. That's 135 degrees. That means that I am in quadrant 2. The reference angle is 45 degrees. So if I draw my little triangle, this is 45, 1, 1, square root of 2. Sine is opposite over hypotenuse. So I get sine inverse. And since it is in quadrant 2, sine is positive in quadrant 2, so I have 1 over the square root of 2, or rationalize radical 2 over 2. I'm now doing an inverse, so I'm restricted to my restriction of negative pi over 2 to pi over 2. That's this little guy. It's a positive ratio, so I am in quadrant 1. Pi over 6, pi over 4, pi over 3. And the angle in quadrant 1 that gives me that sine is radical 2 over 2 is pi over 4 because it has to have a reference angle of 45 degrees. I just drew the triangle for sine. So my final answer is pi over 4. Okay, let's go back to type 1 and type 4. So type 1 was when you had to do the domain. So what you do is you, again, look at the inside function. And so you have y is equal to cosine inverse of x. And you think about the domain, which just represents a ratio. So the domain is negative 1 to 1. And you ask yourself, is 1/4 in the domain? Well, 1/4 is between negative 1 to 1, so you can cancel them out, and the answer is 1/4. So you're doing a check. Otherwise, it's undefined. It's either canceling them out or undefined. And then we're going to do type 4, which is the one where you assign an angle. So first you assign an angle. So you get sine inverse of negative 3/4 is equal to theta, which means that the sine of theta is equal to negative 3/4. I can now draw a triangle. Opposite over hypotenuse. I get 9 plus a squared is equal to 16, which means that a will be the square root of 7. I look at how I defined my angle. I defined it with sine inverse. So I am restricted from negative pi over 2 to pi over 2, which is here. But because the ratio is negative, that can only happen if it's in quadrant 4. So I know I am in quadrant 4. I have my triangle. So I look at the outside function. The outside function is cosine. Cosine in quadrant 4 is positive, and it's adjacent over hypotenuse. And you don't have to write the plus. I'm just writing it for emphasis on the quadrant. So here they are, the types 1 to 4 together.